Now, in today's session, we will study about the chemical reactions of amines. Under it, first we will study the basic characters of amines. Yes, now amines react with acid to form salt. Basic character. Amines react with acid to form salt. Similarly, aromatic amine also react with acid to form aniline chloride. So both the reaction shows that amines are basic in nature, and if this salts combine with NaOH, it regenerates primary amine Now amine salts are soluble in water but insoluble in organic solvents like ether. So this reaction is used to separate amines from non-basic organic compounds which are insoluble in water. This reaction can be used to separate amines from non-basic organic compounds insoluble in water. Now, due to the presence of lone pair of electron on the nitrogen atom, amine behaves as Lewis base, and this is also one of the reasons for the basic character of amines. Now, this we can study by applying law of chemical equilibrium. When amines undergoes hydrolysis, it forms ion, and if we apply law of chemical equilibrium, then we will get active mass of RNH3 plus OH minus divided by RNH2 H2. Then second step, KEQ into H2O Now, this Kb is known as dissociation constant for base, whereas Keq is called as equilibrium constant for base. Now, Pkb is equal to minus log Kb. Larger the value of Kb or smaller the value of pKb, stronger is the base. Once again I am repeating, larger the value of Kb or smaller the value of pKb, stronger is the base. Larger value and pKb, smaller value, stronger is the base. Next is the basic character of primary, secondary and tertiary amines. Comparison of basic character of primary, secondary and tertiary amines. Now first factor is that is inductive effect, that is plus I effect. Basic characters of primary, secondary and tertiary amine. First factor is that is inductive effect, ECT. Now with increase in number of alkyl group, the electron density increases. With increase in number of alkyl group, the electron density increases. Therefore, the basic character of tertiary is greater than secondary, is greater than primary. With increase in the number of alkyl group, the positive charge, that is plus I effect, increases. Therefore, tendency to donate will be difficult. Therefore, tertiary is greater than secondary, is greater than primary. Second factor is that is hydrogen bonding. Hydrogen bonding, or you can say solvation of ion. Solvation of ions. Now primary amines, after accepting proton, it form RNH3 plus. So it can form 3 hydrogen bonding. Secondary amine will form 2 hydrogen bonding and tertiary can form 1 hydrogen bonding. So by this factor, basic character of primary is greater than secondary is greater than tertiary. So just reverse order according to the two different factors. Therefore, again, if you change the alkyl group, if you change the alkyl group, for example, methyl group and ethyl group, again, if methyl group is replaced by ethyl group, steric hindrance will come into existence, and therefore the order of basicity will change. So the net effect of these three, that is inductive effect, solvation of ion and steric hindrance, the order of basicity is, if in the case of methyl group it is secondary, then primary, then tertiary, then ammonia. Whereas in the case of ethyl group with amine, the order is secondary, then tertiary, then primary, and then ammonia. So remember, in the case of methyl group it is 213. In the case of ethyl group it is 231. So order of basicity, three factors: inductive effect with increase in the number of alkyl group. The nature of alkyl group is electron releasing group. It pushes the electron towards nitrogen and makes the unshared pair electron more available for sharing with the proton of the acid. Therefore, the order is tertiary, secondary, primary. In the case of solvation ion, the order just gets reversed, that is primary, secondary and tertiary. And third factor is steric hindrance. Steric hindrance with increase in the size, with increase in the size of the alkyl group, steric hindrance comes into existence. So again the order of basicity changes. Next is the basic character of aryl amines. Now the aryl amines, that is aniline. Aniline is less basic than ammonia or other aliphatic compounds because the electron pair on nitrogen atom is involved in resonance. Just like alkyl halides, alcohol, we have drawn the resonating structure. The electron pair of nitrogen is involved in resonance. So total 5 structures are drawn. This electron pair will move this here and this bond will move here. So again electron pair will move here and bond will form here. So you can see that the electron pair which was present on nitrogen is involved in resonance. and last step again. So aniline are less basic than ammonia or aliphatic amine because the electron pair present on nitrogen atom is less available for protonation, not able to give, therefore it is less basic. Now the effect of substituent groups. Now electron withdrawing group decreases the basic character. For example, nitro sulfonic acid, carboxylic acid, whereas electron releasing group increases for example alkyl groups methoxy group, now next is alkylation. Alkylation already we have done. Alkylation, when amine reacts with alkyl halide, it forms R2 NH, again it forms, reacts with RX, it forms R3N, reacts with RX, it forms R4 N plus X minus. So already we have done it. Next is acylation. This reaction is also called as ammonolysis reaction. Ammonolysis reaction. Now acylation. Acylation means the introduction of acyl group. So R NH2 plus CH3 COCl, it will form R NH CO CH3. So it is called N alkyl ethanamide. If we take secondary amine, then it forms this is CH3. So it will form secondary amide. N dimethyl ethanamide. Similarly, this can react with aniline also. Now next is carbylamine reaction. One more reaction we can write, that is benzoylation. Benzoylation, that is reaction with benzoyl chloride. For example, that is methylamine reacts with benzoyl chloride. It forms CH3 NHCO C6H5. So it will be N-methyl benzamide. Next is carbylamine reaction. Carbylamine reaction is used to distinguish between primary, secondary and tertiary amine. It is given only by primary amine. It is given only by primary amine RNH2. So we can take the example CH3 NH2 reacts with chloroform and a base potassium hydroxide. It is heated to form RNC. It is, here we have taken R is CH3 we have taken, so we will write down CH3. CH3NC, that is methyl isocyanide plus 3 KCl plus 3 H2O. Very important reaction. It is used as for the test for primary amines. Pungent smell, irritating, cannot be tolerated. It's also called as isocyanide or methyl carbyl amine. This reaction will be given by aniline also. This reaction will be given by aniline also. Next is reaction with nitrous acid. Now, primary amine reacts with nitrous acid HNO2. It forms benzene diazonium chloride. If this temperature increases, it forms alcohol. So this is unstable. Temperature, if it is increases, it decomposes. So this reaction is used for quantitative analysis of amino groups and protein. We can know the amount of nitrogen involved. So this reaction is used for the estimation of amino acids and protein. Second is aromatic amines. They forms aromatic amines, that is now nitrous acid is obtained, all of you know, from NaNO2 plus HCl. This gives you nitrous acid. Temperature is 0 to 5 degrees centigrade. It forms benzene diazonium chloride N2Cl, benzene diazonium chloride plus H2O. Secondary and tertiary amine, they react differently with nitrous acid. So this reaction, basically we cannot use this reaction to distinguish between the primary, secondary, tertiary amine, because no color distinction can be shown by this reaction. Now the third reaction is, that is reaction with aryl sulfonyl chloride. Reaction with aryl sulfonyl chloride. It is also known as Hinsberg's reagent. Hinsberg. Hinsberg's reagent. Now Hinsberg's reagent is C6H5SO2Cl. It is called as benzene sulfonyl chloride. Benzene sulfonyl chloride. Benzene sulfonyl chloride reacts with amines, primary amines, that is CH3NH2. It will form C6H5SO2 NHCH3. It is called as N-methyl benzene sulfonamide. N-methyl benzene sulfonamide, which is soluble in KOH. Soluble in KOH because of the presence of acidic hydrogen. Because of acidic hydrogen. Secondary alcohol reacts Secondary alcohol also react with benzene sulfonyl chloride, benzene sulfonyl chloride reacts with secondary amine, that is CH3 whole twice NH. So it forms C6H5SO2 and CH3 whole twice. It is called N dimethyl benzene sulfonamide, insoluble in KOH, insoluble in KOH because of absence of hydrogen. And tertiary amine, no reaction. Tertiary amine, no reaction. So this two reactions are very important. First is carbylamine, which is used to distinguish between primary, secondary and tertiary amine. So primary amine will give the test, secondary and tertiary will not. And the reaction with benzene sulfonyl chloride, that is Hinsberg's reagent, it is used to distinguish between primary, secondary and tertiary. Primary will react and it will dissolve in KOH, whereas secondary amine will also react but insoluble in KOH, and tertiary amine no reaction. Next is electrophilic substitution reaction. Electrophilic substitution. Now electrophilic substitution reaction, under it first we'll study that is bromination. Now when aniline reacts with bromine in the presence of water, that is bromine water, it forms tri-substituted tri-sub 4 6 tri bromo aniline. In the reaction is this highly, the bromination is very fast. So if we want to make a monosubstituted product, then production of amino group is done. Production of amino group is done. So for that, first aniline reacts with acetic anhydride. Aniline reacts with acetic anhydride in the presence of pyridine. Then the activity of amino group is reduced. The activity of amino group is reduced by acetylation. So it forms N-phenyl ethanamide. Now this reacts with bromine and acetic acid, then it forms monosubstituted product PR. This on acidic or basic hydrolysis, it will form parabromoaniline. So why it is so? Because the lone pair of electron present on nitrogen involves in resonance when acetylation is done. Why the activity of amino group decreases? Because the lone pair of electron present on the nitrogen atom is involved in resonance and therefore less available for donation. If you want, we can draw it. N C double bond O CH3. Now the lone pair of electron present on nitrogen is involved in resonance. So it will form here double bond and positive charge, single bond, O. So the electron pair of nitrogen is involved in resonance. That is why it is difficult to donate. Therefore, activating effect of NH2 group is decreased. A second example we can take is nitration. Now aniline reacts with nitric acid and concentrated H2SO4, temperature 288 Kelvin. It forms 3 isomers. Para, meta and ortho. All the 3 isomers are formed. Now we can ask questions that since NH2 group is ortho and para directing, but why meta isomers are formed? And this is because in the strongly acidic medium, the NH2 group accepts proton and becomes anilinium ion, which is meta. The NH2 group in the strong acidic medium accepts proton to form aniline amine, which is meta-directing. Again, this question is also asked many times in board, why it forms meta-isomers. So more amount is formed of meta-isomers. Now again, if we want to prepare monosubstituted product, then the same procedure, that is acetylation of amino group, will be done first. Then we can get monosubstituted product. So aniline first will react with acetic anhydride in the presence of pyridine. It will form acid analyte NHCOCH3. So it is also called as, common name it is acid anilite, which now can react with nitrating mixture, concentrated HNO3 and concentrated H2SO4 to form OH minus Now next is sulfonation. So when aniline reacts with sulfuric acid, it forms anilinium hydrogen sulfate NH3 plus HSO4 minus. It is called anilinium hydrogen sulfate. Now this in the presence of 453 to 473 Kelvin. So here the proton transfer takes place. When it is heated, it forms NH2 SO3H. It is called as sulfanilic acid. Sulfanilic acid. The sulfanilic acid, after the proton transfer, NH3 plus and SO3 minus. So this sulfanic acid behaves as bipolar ion. Bipolar ion, also called as Zwitter ion, behaves as internal salt, behaves as internal salt because both acidic and basic groups are present. Now aniline do not undergo Friedel-Crafts reaction. Aniline do not undergo Friedel-Crafts reaction because of the salt formation with aluminum chloride. Aluminum chloride is a Lewis acid, whereas aniline is a Lewis base, and due to this the nitrogen of aniline acquires positive charge and hence act as a strong deactivating group for the further reaction. Now in today's session we have studied the basic properties of amines and the comparison of the basic character of primary, secondary, tertiary amines and the chemical reactions of the amines.